All right, let's dive into something truly mind-bending today. One of the strangest, but also one of the most powerful ideas in all of physics, quantum superposition. This is the idea that the very building blocks of our reality, well, they exist in this strange, ghostly state of all possibilities at once, only snapping into the world we know when we actually look at them. So let's just start with a question that sounds like it should be simple, but the answer is anything but. Can a single object be in two different places at the exact same time? I mean, your gut reaction, my gut reaction, everything we know from our daily lives screams, no way. But down in the quantum world, the answer is a definite yes. And that's where our journey begins.
So, how in the world is this possible? To get our heads around it, we've got to look at what might be the most famous and, honestly, the most baffling experiment in the history of science, the double-slit experiment. It's the perfect showcase of just how weird quantum mechanics can be. Picture this. The setup is actually pretty straightforward. You've got a barrier, and in that barrier are two very thin parallel slits. On one side, you have a sort of gun that fires individual particles. You can think of them like tiny, tiny bullets, like electrons, one at a time. And on the other side, there's a detector screen that just records where each of those particles lands. Seems simple enough, right?
I mean, common sense tells you exactly what should happen. Each particle is its own little thing, so it has to make a choice. It's either going to go through the left slit or it's going to go through the right slit. So on the screen behind it, we should see two nice, clean bands of hits lining up perfectly with those two slits. That's the logical, classical world we think we live in. But that is not what happens. Not even close. Instead of two simple bands, what we see is a pattern of many bands, what's called an interference pattern. Now, this is exactly the kind of pattern you see when waves, like ripples in a pond, pass through two openings. The waves spread out, they interact with each other, they cancel each other out in some spots, and build each other up in others. The only way this result makes any sense is if each particle isn't behaving like a bullet at all, but like a wave that goes through both slits at the same time and literally interferes with itself. And that right there is the heart of the mystery. How can a single particle be in two places at once to create a pattern like this? It seems to break every rule we know about how the world works. But this isn't some kind of trick. It's a fundamental truth about reality. And the answer? Well, it lies in our main topic today. The explanation for all this quantum weirdness has a name: superposition. And this one idea doesn't just solve the puzzle of the double-slit experiment. It's the key to understanding the entire foundation of the quantum world.
So what is it exactly?
Well, quantum superposition is a core rule of quantum mechanics. It says that as long as you're not measuring or observing a particle, it doesn't really exist in one single definite state. Instead, it exists in a combination, a superposition of all its possible states, all at once. So that electron in our experiment, it didn't go through the left slit or the right slit. It was in a superposition of going through both. Okay, to make this a little more concrete, let's compare our normal world with the quantum one. A regular computer bit in your phone or laptop is like a light switch. It's either on or it's off, a 0 or a 1. That's it. But a quantum bit, or a qubit, is totally different. It exists in a superposition of being 0 and 1 at the same time. The best analogy? Think of a spinning coin. Before it lands, it's not heads and it's not tails. It's a blur of both possibilities at once. That's superposition in a nutshell.
Now, you might be thinking this is just total chaos, but it's not. This weirdness actually follows some very specific rules. And understanding these rules is the key to figuring out why we don't see things in two places at once in our everyday lives.
And the biggest rule is all about what happens when we look. The second we try to measure a system that's in superposition, the weirdness just vanishes. As the great physicist Paul Dirac put it, if a particle is in a superposition of being in state A and state B, your measurement will always find it in either A or B, never in some weird state in between. The very act of looking forces the particle to pick a side, to choose one single reality. This is what's called the collapse of the superposition.
And this is where it gets even stranger. It's all about information. Physicist Anton Zeilinger explained that superposition only holds up as long as there is absolutely no way to know, even in theory, what state the particle is in. Think about that double-slit experiment again. If you put a little detector by the slits to see which path the electron actually takes, the interference pattern completely disappears. The simple act of gathering that information, even if you don't look at the results, is enough to destroy the superposition. It's like the universe gets a little camera shy.
Okay, so at this point, you might be thinking, this is all just wild, abstract theory, right?
Well, nope. Superposition isn't just a concept on a blackboard. Physicists have been creating it and observing it in labs for years, with objects that are getting bigger and bigger.
And the scale of these experiments is just incredible. Scientists have trapped a single ion and put it in a superposition of being in two different places. They fired these big molecules called buckyballs, that's 60 carbon atoms, through double slits and watched them interfere with themselves. They've even taken a tiny tuning fork made of literally trillions of atoms and put it into a superposition of vibrating and not vibrating at the same time. And this isn't just in the lab. There's growing evidence that photosynthesis, the process plants use to create energy, actually uses superposition to move that energy around with incredible efficiency.
So, just how big can we go? Well, so far, experiments have successfully put molecules with over 800 atoms, weighing more than 10,000 atomic mass units, into a quantum superposition. We are getting closer and closer to that fuzzy boundary between the quantum world and our everyday classical world, proving this stuff isn't just for the smallest of the small.
Look, this is fascinating, mind-bending stuff, but what's the point? Why does mastering this strange principle actually matter for our future?
Here's why it matters so much. Superposition isn't just a weird quirk of nature, it's an unbelievably powerful resource. It is the fundamental engine that's going to drive a whole new technological revolution, quantum computing. Harnessing this weirdness is the key to unlocking a kind of computational power we can barely even imagine today. So here's the basic idea. The computer or phone you're using right now runs on bits, which can only be a 0 or a 1. A quantum computer, on the other hand, uses qubits. And because a qubit can be both 0 and 1 at the same time thanks to superposition, it can explore a massive number of possibilities all at once. So 2 qubits can explore 4 states at the same time. 3 qubits can explore 8. That power grows exponentially. This allows quantum computers to tackle problems that would take the fastest supercomputer we have today literally billions of years to solve. And that brings us right back to where we started, but with a much deeper question. Superposition tells us that at its most fundamental level, reality isn't this solid, certain thing we think it is. It's more like a shimmering cloud of probabilities, a wave of possibilities that only becomes real when we look at it. Which leaves us with a final, pretty deep thought. If the very foundation of our universe is built on chance and probability, what does that mean for our reality? What, if anything, is truly certain?